Hello everyone, my name is Remi Lawal and I'm from Louisiana State University. In this poster, I'll be talking about the work we've been doing using a deep ultraviolet laser to ablate tissue sections for localized proteomic analysis. And the goal of this work was to develop a method that we can use to precisely remove small regions of interest in a tissue section for offline characterization of this biomolecule using mass spectrometry. And this is highly crucial in achieving spatially resolved proteomics. We know that a tissue section is highly heterogeneous, that is, different regions of the tissue will contain different population of biomolecules. With spatially resolved analysis, we can identify these proteins as well as acquire information about where it is localized on the tissue section. And to achieve this, we used for the very first time the 193 nanometer wavelength laser to ablate different regions of the tissue section and collected this ablated material. The sample is then characterized using bottom-up proteomic approach coupled to tandem mass spectrometry. While the 193 nanometer wavelength laser is advantageous for high precision sampling, there is the concern that this wavelength will fragment or damage these protein molecules. So first, to characterize potential fragmentation of proteins with this wavelength, the 193 nanometer wavelength was used to ablate albumin standard, and the standard was then analyzed with Malden. And the result revealed that the peaks that were detected correspond to intact molecular ion peak of the albumin protein, and there was no indication of fragmentation. Next, this wavelength was used to ablate tissue section, and the proteins extracted from each area was characterized with Bradford assay. And the results showed that proteins were successfully extracted from this tissue using the 193 nanometer wavelength laser. About 2000 nanogram of proteins was extracted from the 1 millimeter square area. Then these proteins were identified using the tandem mass spectrometry analysis, and we found thousands of proteins in each of this area. But the interesting result was that when we compared this result from the UV to previous result that has been done using the infrared laser to sample tissue, we found that the UV was at least 4 times more efficient in extracting proteins from tissue compared to the commonly used infrared laser at 2940 nanometer wavelength. When we compared the number of proteins and the number of peptides, there was also 4 times more identifications with the UV. To conclude, we found that the 193 nanometer laser is able to ablate biomolecules without fragmentation, and it was 4 times more efficient at extracting tissue proteins compared to previously used infrared laser. With that, I'd like to thank NSF for funding this project. I also thank the organizers of NOBCChE for putting together this virtual conference. Thank you for listening.